This will be 0 volt, 10 volt, 20 volt, 30 volt. Now, these are some troublesome diagrams will be given for you. So these are the lines of force. These are equipotential lines. Arising from a static charge. Has been shown in a region. These are the equipotential points here. Now, can you say about the lines of force at point A, then at B, then at C? Is asking us to roughly, can you predict about how the electric field lines will be at A? And if I release charge at A, will it move along the field line passing through A? So I'll dictate the question. First one, draw the electric field lines. Roughly, it's asking to predict the lines of force. If a charge, if charge is released at point A, will it move along the field passing through point A? What is the work done in moving a charge from A to C? Third one, work done by external agent in moving a charge of 2 coulomb from A to C. Okay, very simple idea I brought it. These are equipotential surfaces. Can we say anything about the lines of force? What is the basic method? How the lines of force should be? Should be directed from higher potential to lower potential. The electric field line should be directed from higher to lower potential. Will I agree this? Because the electric field will be directed from higher to lower potential. So therefore, the if I'm plotting, and what is the method? The lines of force should be perpendicular to what? To equipotential surfaces. Yeah. Now what shall I do? I'll keep point A here. We will directly start from here. The lines of force I should draw in such a way that it should be perpendicular, no? I'll continue, just make observation. So it should be everywhere, it should be perpendicular. Hope I'll try to. Everywhere you have to see that it will be perpendicular to the equipotential. There's a one basic necessity condition. Similarly, what happened? We can try another line here. Is it a uniform or non-uniform electric field? I think I can do only this much here. Is it a field is uniform or non-uniform, you suggest? Will be non-uniform. The field will be in fact non-uniform. Okay, there's a point B. How the arrow you have to show in this way, no? I think this is the correct one. Getting this? Okay, after this, no. If the charge is released at point A, will it move along the field passing through point A? Means along the lines of force. I'll release a test charge here. So will it move in this direction? Anybody? Already we have discussed this concept, no? Anybody wants to say yes or no? If a charge particle, test charge, is released at point A, it will move along this red color line. Yes or no?
Yes, sir.
Please think once and answer yes or no, because we are going to almost conclude this very important. If I release it, will it move along this direction? When the charge particle will move along lines of force, only in case of isolate field produced by isolated point charge. Am I right? I gave exclusively this explanation also with the help of diagram. If a test charge is released, it will move along the lines of force when it is possible in case of only field produced by isolated point charge. What is this field? This is not produced by isolated point charge. So definitely what you can say that one. It will not move along lines of force. The answer is no. So what are lines of force? Is it a path traced by the test charge released in that field? The answer is no. So what is the lines of force? If you draw a tangent, it will give the resultant T bar. Work done by exchange agent in moving a charge of 2 coulomb from A to C. What shall I do? Work done by exchange agent in moving a charge from A to C should be equal to Q into VC minus VA. Q, 2 coulomb. What is VC? VC is 60 volt. VA is how much? 90. 60 joules of minus 60 joules of work is what it should do. Now, the test charge, if I release here, can it reach point C? If I release test charge at point A, will it reach C? No. We can't say like that because the electrostatic force cannot move the test charge along the lines of force. Exchange agent I can move, but will it depends on path, how I move? This answer, minus 60 joules, will it depends on path? Means I'll move like this. Then I'll move like this. Then I'll move in this way. Will it depends on path? No, independent of path here. Again, this answer is any reason? Because it's a conservative field, no? Because what all this field is a conservative field. Because sir, how you can say conservative field? I have here, look at this. The field produced by static charges must be conservative. Getting some very generalized conclusions there. Any doubt you can clarify? Any doubt if you have, you can clarify. It's a very good conceptual things. May not be good numericals or not there, but there's a very generalized today what we discussed, no? Huge applications. When we go for next chapter, no, these are the things which will help us, not like something like a finding electric field due to line charge. Okay, those things may not help us. But today's concept is what? are very fundamental. I'm making things clear. They're very, very, very fundamental. So let me summarize once again. If you release a test charge in an electric field, first of all, the field produced by static charges will be conservative. Okay, fine. If you release a test charge in an electric field, it need not move along lines of force. If you release a test charge in a field produced by isolated point charge, it will move. This is not field produced by a point charge. So it didn't say no, static charge is said. So therefore, it will not move along the lines of force. Then what is another condition? The lines of force should be, E bar should be directed normal to the equipotential surface. This is a basic condition. Then afterwards, then two lines of force, can they intersect? No. Two equipotential surfaces, can they intersect? The answer is no. Because if the two equipotential surfaces intersect, then what is the problem? At a given point, you may get two E bars. Not possible, no? There should be only unique. The direction of electric field is unique. It cannot have two different directions. So two equipotential surfaces cannot intersect. Lines of forces cannot intersect. Lines of force will be directed from higher to lower. The electric will be directed from higher to lower potential. If the spacing between the lines is less, the field strength should be more. Okay, all these are some general things. If they give lines of force, you should know what all the features. If they give equipotential, you should know what are the features. And once again, I want E equal to potential difference equal to E into D. What is delta V? Potential difference between 2 points which are separated by distance D, where the D is measured in the direction of E. This is applicable for uniform electric field only. Field is non-uniform, we should go for integration. And the electric field lines will be always directed from higher to lower potential.